Hey everybody, Mr. Wyatt here, and we're going to go through a few of the problems from today's review worksheet. And so I'm looking here at a problem number one. It says to estimate the area of the figure shown below. Now it's kind of a crescent moon shape. Um, to find its area, we don't have a formula for anything like this. All I need to do is kind of figure out, like it's on a grid right now. Let's see if we can figure out how many squares are inside of this crescent shaped figure. And then we're going to look at our answer choices here, 15, 32, 40, and 11 square units, and try to figure out which of those would be closest to being correct. So what I would do on a problem like this is actually just start counting the squares. Each square would be a square unit. Whatever the unit of measurement is, we don't know. It doesn't say. So let's look for complete squares. Like here's a complete square. I'm going to count them as I go. 1, 2, 3, 4, 5, 6. That's all the complete squares. And then I'm going to look for ones that are like almost complete and count them. Like this one here, 7. This one is almost complete. We'll call that 8. This one's almost complete, 9. That This one's almost complete, 10. This one's almost complete, 11. Um, and and then I can start combining some different parts here. Like I could combine, this looks like about half of a square. If I combine that with maybe this, which is half a square, that'd be 12. These I maybe could combine, call it 13. Maybe combine these, call it 14. Maybe combine these, call it 15. There is another section over here. But maybe 16 if you were to include the other ones there. But when I look at my answer choices here, 15 is really close. I like it. 11 is not nearly enough. I mean, we counted 11 and still had quite a bit left after that. 32 and 40 are way too big. So 15 square units seems like the most reasonable estimate for the area of that crescent shape. Okay, so we're just counting up squares and then piecing some little partial squares together when counting them. All right, number two, which rule generates the quantities in the table below? Here I have a table, and this is called an XY table. Sometimes we call this an input-output table. X is your input value. Y is your output value. But I like just calling it an XY table because it's just a little bit quicker to think of it like that. But when you have these equations, y equals 6x minus 5, y equals 2 minus 7x, y equals 4x minus 19, y equals 6 minus 5x, two of them already look suspicious to me, this one here and this one here, just because they're written backward. Normally you'd have your x's right after the equal sign, kind of like here and here. So what you can do is you can test out each of these. Like let's try y equals 6x minus 5 and see if it generates these quantities over here. Okay, so y here is 1. Does that equal 6 times x? Well, what is x here? X is 1 minus 5. Well, 6 times 1 is 6. 6 minus 5 equals 1. It worked. Does it work with this second one? We have a 2 here, we have a 7 here. So y, 7, does it equal 6x minus 5? 6 times 2 minus 5. Well, 6 times 2 is 12. 12 minus 5 does equal 7, so these do match. It worked again, didn't it? Y equals 6x minus 5. By the way, there are some other hints that would show us that this is actually going to be the right answer. When I'm looking at my input or my x's, do you see how they keep going up by 1 each time? We keep just adding 1 here and adding 1, adding 1, adding 1. When they go in order like that, Look to see how your y's are increasing. It's going up 6 here. It went up 6 here also. It went up 6 here. It went up 6 here as well. It keeps increasing by 6. So y is going up by 6 every time x goes up by 1. That actually tells me something important. The amount that it's increasing each time is what I'm going to have to multiply by. So we take 6 times x. It happens that way every time. So anyway, if you do that though, I mean, if you take 6 times any of these, like 6 times 5 is 30, you end up having to subtract 5 to land on the y value. So yeah, it does work every single time. Okay. Fortunately for us, it was the first one that worked out. I kind of decided not to even look at these two because they just looked a little bit funny to me, like the way they were written. They just looked a little backward. This choice here, y equals 4x minus 19, you could test it, but if you take 4 times 1, you'd get 4. If you then subtract 19, you'd be in the negatives. You wouldn't get positive 1. So that one clearly doesn't work. Okay, but that first one, y equals 6x minus 5, will work every single time for any of those values. All right, number 3, or number 4, what percent is equivalent to the fraction 3/8? Let's write that fraction the way we normally write fractions, like this, 3/8. Okay, how do you change that into a percent? Well, there actually are a couple of options on how we could do this. I'm just going to put a little line over here because I'm going to show you 2 ways to do this. Most people would do it this way. I'll show you what to do here. The fraction bar means divide. It always means division. So let's divide 3 by 8. I'll put a decimal point here and add some zeros. Bring the decimal point up here in the quotient. 8 will not go into 3. I'll put a 0 there. But 8 does go into 30 3 times. 3 times 8 is 24. I get a remainder here of 6. And I'll bring down the next digit, which is a 0. Now, 8 will go into 60 7 times. 7 times 8 is 56. Subtract that from 60, we get a remainder of 4. Bring down another 0. 8 goes into 45 times. 5 times 8 is 40. And I get a remainder of 0. So 3/8 equals 0.375. Now, we do need to be careful because it's going to be really tempting then to select this one right here for our answer. It says 0.375. But see, this is our decimal value of 3/8. It's not our percent. This actually is wrong. Because to change a decimal into a percent, you need to take the decimal point now and move it 2 spaces to the right. And we end up with 37.5%, which actually makes a lot more sense. If you have 3 out of 8, like if you and I have 8 candy bars, if I give you 3 of them, I get the other 5. You got a little less than half, didn't you? 3 out of 8 would be a little less than half. 37.5% would be a little less than half too, wouldn't it? So yeah, it just seems reasonable as an answer. Now, there is another way we could solve this problem. We could use a proportion. 3/8. If we want to know what it is as a percent, that means we want to know what it equals out of 100. It has to equal something out of 100 to be written as a percent. And then what you can do is just cross multiply to solve this. 8 times x has to equal 100 times 3. So 8 times x has to equal 300. And then you can just divide by 8 on each side to solve this equation. So what does x equal? Well, we'll just divide 300 by 8. I bet you know what it's going to equal. 8 times 3 is 24. We get a remainder of 6. Bring down the 0. 8 times 7 is 56. We get a remainder of 4. Since I did not get a remainder of 0, I need to add a decimal point and a 0. Bring the 0 on down, we have 40. 8 does go into 40 5 times. And now we have our remainder of 0. So you can see I got 37.5 this way also. And that is our percent right away because it's all out of 100, and that's what percent means. It means per 100. Okay, let's look at the next problem here. Number 5, find the measure of the missing angle, H, in this trapezoid. You know, this trapezoid, it's made up of 3 triangles. This middle triangle has a 60-degree angle here, a 60-degree angle here. Well, triangles always, the angles always add up to 180 degrees. So what that tells me is that, 60 plus 60 is equal to 120. So now how many degrees will it take here to get this up to 180? Well, you can take 180, subtract 120, and guess what? It equals 60 degrees. That means this angle here is 60 degrees. Okay? Now, actually what we have here is what's called alternate interior angles. Those are always going to be congruent, alternate interior angles. See, we have parallel lines here. If you imagine a line coming across the top here, and a line coming across the bottom, because in a trapezoid, you always have 2 sides that run parallel. And these dashed lines are transversals. So you can think of this right here as being a transversal cutting through here, cutting through the parallel lines. And so this angle here and this angle here are both interior angles because they're inside the parallel lines. And they're on alternating sides of the transversal. So they have to be congruent. They have to have the same measurement. Angle H then has to be 60 degrees. Okay? And they kind of all look like they're identical triangles too. You may have been able to look at this figure and recognize, hey, these 3 triangles are all identical to each other. So they must all have the same angle measurements in them as well. So angle H there is 60 degrees. All right, number 6, let's order these from least to greatest. This one's a little tricky because we have fractions and we have decimals. I think the easiest way to handle this would be to just change everything into decimals. 1/5, just divide 1 by 5, and it equals 0.2. This one's already a decimal, 0.5. This one's already a decimal, 0.05. This one's already a decimal, 0.23. And then 1/3, you can divide 1 by 3, and you're going to get 0.33. The 3's just keep repeating, okay? But when they're all written as decimals, it's going to be really easy to compare them. Now, the other thing I notice is some of these are going 2 places or more past the decimal point. A couple are only going 1 place past, so you could show the second place, the hundredths place, by just adding a 0. And then we can just compare them easily now. This is clearly the smallest, 0.05. All right. Then we have our 0.20 and our 0.23. So 1/5, this one, the 0.20, would be next. 0.23 would be the third one. So that takes care of those 2. And then between the 0.33 and the 0.50, 0.33 is the next smallest. So that would be 1/3. And then finally 0.5. And if you take a look here to see where that happens to be, it's this choice right here. All right, we're starting to run low on time. I don't know if I have time for this last one or not. We want to know the measurement of angle K. It's an obtuse angle. What you got to do? Well, I'll have to show one more video here to fit this in. Okay, so I'll make one more video and attach it here. Okay, I'll see you later.